Support for the series on women in science and tech comes from Genentech, dedicated to breakthrough science and social good that supports local communities. Because making medicine is just one way to make a difference. Genentech, the future of science is here. Online at gene.com/future.
Hello, I'm Kamla. My guest today is Dr. Isabel Hawkins. She's an astronomer, an educator, and a competitive salsa dancer. Welcome, Isabel.
What a combination. Hi, Kamla. Thank you for having me.
It's a fantastic combination, stars and stars. You're a star on the stage, and then you look at the stars in the sky. How many stars are there in the sky that we can see?
When you go out on a very dark night when there's no moon, for example, and you are getting away from the city lights, your own eyes can see up to 6,000 stars in the entire neighborhood of the sun.
But there are more than that, right?
Yes, there are
galaxy.
Many more. Just in our own galaxy, which is our own family of stars where the solar system sits, called the Milky Way, there are 12 billion stars. But our own eyes have limitations as to what we can see, what we can detect. So we can only detect a very, very small fraction.
Wow. How big is the universe?
The universe is as big as light lets us see coming from distant quasars and distant galaxies, because light has a finite speed. And
so we measure in light?
We measure in light years, so the amount of time that light traverses or travels through, the amount of distance that light travels through in 1 year, that's called a light year. It's a unit of distance, not of time. And so basically we can see about 13.7 billion years back. That is how old the universe is.
The Big Bang Theory?
Yes, coming from the Big Bang Theory. That's when the Big Bang took place, the big original explosion that began this expansion of the universe, taking us with it.
So is the universe expanding, contracting? What is happening?
The universe is expanding and accelerating. So
how do we know that?
There is a pretty recent discovery called dark energy, which is a force that is accelerating all of the galaxies away from each other. And so our universe is really expanding and accelerating.
So if it is expanding, how can we measure it?
We can measure it through what is called the redshift, or the way that light becomes redder or longer wavelength as an object moves away from us.
So that's how we measure.
Yeah.
How did you get interested in stars?
Well, when I was a little girl, we used to go out into this very remote location for summer vacations with my family.
Where was this?
I was born in Cordoba, Argentina. And so we would go out to this ranch, and it was so hot and miserable in the evenings and in the summer. And there was no running water, no electricity. So before night would fall, we would take the mattresses out and we would sleep outside, all the kids would, because it was perfectly safe. We were in the middle of a ranch, the cows were mooing. I mean, it was beautiful. And on a moonless night, you could almost touch those stars. It was so beautiful. And I was fascinated by the darkness of the sky and also the shooting stars.
Which are meteors.
These are meteors, yes, meteors that enter the atmosphere and they will ignite and look like a star is actually falling, but it's not a star, of course. But I thought it was stars, and so then in the morning I would get up, all my friends said, let's go get it, because it fell behind the tower there, or the water mill, or whatever it was. And so we would just go, you know, and of course never found the star, but that was my source of inspiration.
Any books inspire you?
Yes, I was fortunate that my family could afford books, and especially buy books that were extracurricular from our needs for the school. And so I was grateful that sometimes we would get these encyclopedia salespeople that would come to the house, and they would just display these beautiful books, and they would smell so good. You know, you open these pages and the feel of it. And there was this one special book on astronomy and on the solar system, and I was fascinated by Jupiter, the biggest planet, and it was such a beautiful photograph, color photograph. And so I just fell in love with the stars and the planets. And I wanted to be an astronomer without really thinking what that would entail, but I was on my way.
So as a 10-year-old, you kind of knew that's what you wanted to study.
Yeah, that was just my interest and my fascination, but I really didn't know what path of or what career. You know, nobody in my family was a scientist. My dad was an accountant. My
your mom
was a teacher, retired teacher. But I think she probably had the knack of a scientist, I would say.
Why do you say that?
Well, I remember anytime anything broke in the house, you know, especially any appliances or anything went wrong with electricity, whatever, she knew all the components of the house, and she was the master of the screwdriver. You know, she'd take everything apart, no fear. I remember the kitchen table, a round table very much like this, would become her workshop, and she would take it apart and fix things. And I remember one time she was reading the paper, and I said, "Mom, if you could have gone to college, what would you have studied?" And without hesitation, she says, "I would have been a chemist." And that really surprised me. You know, I mean, if she had said I would have been an engineer, I guess with all that screwdriving, I would have said, you know, yes. But a chemist, interesting.
So then when you were 16, you came to this country as an exchange student.
Yes, I applied to American Field Service, which is this international program of student exchange. And I was accepted, and I came to Los Altos High School. That's where
Which is
I
right
ended
here.
up. Right here, right here.
So,
Yeah.
so has the Silicon Valley changed since you first came?
Oh my gosh, yes. I mean, I remember, you know, Hewlett Packard and their garage story, you know. I mean, that was the very beginning, I think. And Dr. Noyes as well. I remember actually going to Dr. Noyes' house. It was fascinating, you know, just to...
Dr. Noyes of Intel.
Yes, of Intel. So that was a long time ago. That was in the mid-70s.
And there were still orchards in Mountain View?
Yes, yes, definitely.
Okay. So you spent a year here. You go back to Argentina.
Yes.
And then you come back because you had fallen in love with your high school...
Sweetheart, yes, yes. So I came back, and I was married to my husband, John Hawkins.
How old were you?
I was 18, and he was 21.
Your parents said okay?
His parents said okay. I think, you know, my parents came actually and met the family here, a lovely family. And, you know, if there's love, there's a lot of good things that can happen.
So did you know what you wanted to do? Because as a 10-year-old, you fell in love with stars and the space and everything. And at 18, you're married.
Yes.
Then how did you know what you wanted to become? I'm not saying that marriage is be-all and end-all, but sometimes when you get married, you're busy settling down.
Yes, I agree. But we had decided that we would postpone having children until we were done with school, because it was important for both of us to go to school. And my husband's a physician, a retired psychiatrist. And I wanted to study astronomy. So when I came to Los Altos High School, I was able to take an astronomy class in high school. Very unusual. I mean, that is actually an amazing thing when I think back, the fact that they had a high school astronomy course. And so I was able to understand about, you know, the celestial coordinate system and bring some order to my original passion of just observing the sky, which is a beautiful thing to do. But this kind of presented to me the tools of astronomy, and it was clear that mathematics and physics were precursors, and so...
And you were good at them?
Yeah, I was good at them, and I enjoyed them. And unlike my mother, I did not like chemistry, even though I had to take it, but I preferred
And what about
physics.
biology?
Biology, too messy. I really preferred physics, yeah, and math, and I felt that they were much simpler, much more straightforward. They are, really. I mean, things get very complex with chemistry and biology. You know, the human body is...
Things get very complicated.
Very
with math.
complicated, yes. And if you try and set up models to explain, you know, living systems, you know, that's very complex. But so then I went to UC Riverside, University of California, all the way to get a physics degree, and then from there to UCLA for
PhD
master's
in
and
astronomy.
PhD in astronomy.
Did you ever think of becoming an astronaut?
When I was studying physics at UC Riverside, I did apply to NASA to become an astronaut. I remember filling the application with pen, you know. before the time of the computers or even a typewriter. I didn't have a typewriter. And I sent it in, and they wrote back saying, well, you need to have a PhD first. In those days, you had to have a terminal degree.
Why
before.
a PhD?
I don't know. That says you're studying astronomy, you need to have your PhD before you apply. Now, of course, if you have if you're a pilot or you have an engineering background, or even a medical background, those are different ways in which you can get into the astronaut corps, but not in those days. And so I said, okay, I'll get a PhD. But then after that, we came back to Northern California again, and I did a postdoc at Lawrence Livermore Lab at the physics department, and also at UC Berkeley Space Sciences Lab, where I ended up spending 20 years doing research on NASA satellites. And then I had my girls, and it was time to just settle. And the astronaut bug didn't come to bite anymore.
Okay. So you became an astronomer. So I'm sure there are people who come and ask you, because you're an educator, you do a lot of outreach programs, yes. You work with the Exploratorium. Do they ever come and ask you, what are the practical applications of studying astronomy?
Yeah, there's so many amazing things that have come out of astronomy. I think because it is an interdisciplinary endeavor. To be an astronomer, you have to be a good computer scientist too. You have to be able to code, use the computers.
Do you code?
Yes, I did. I did the software system for the Extreme Ultraviolet Explorer satellite for one of the NASA satellites at Berkeley. So we supervised that whole software system. And then you also have to know a bit of chemistry if you're doing chemical compositions of stars and studying that. You, of course, have to do physics. If you're designing instrumentation, you have to know all the engineering and design. So there are many good skills that come out of being an astronomer. So if somebody out there is interested in becoming an astronomer and your parents or someone else says, you'll never get a job, that is absolutely not true. You might not get your tenure track professorship at Harvard University or whatever, if that's a goal, but because it's very difficult, there are very few of those positions. But there are so many other amazing jobs. And my favorite is to work at a science museum. So I think it gives you a variety of skills. And there are many particular technologies that have been applied to defense, for example.
Like what?
For example, guiding systems for
like the
missiles, yes, things like that.
How is astronomy applied there?
Well, basically, when you launch a satellite into space, you have to know where the satellite is pointed, and you have to be able to send commands to point the telescope.
This is before GPS?
Before GPS. You have to send commands so that you can point the telescope to a particular location in the sky that you want to study. And so the way that was done was through gyroscopes, so to know where the satellite is with respect to the Earth, but also with a system called star tracking. And star tracking is a way of measuring positions of many stars in the sky that are then compared to catalog positions, the positions that we have measured with great precision, and then you make adjustments, and that tells you where the telescope is pointed. And it's amazing that even birds, when they migrate, they actually use a star tracking system of their own. I read that in Scientific American because I'm not a biologist and I'm not anything to do with birds, but I found it fascinating that the birds also use star patterns to guide themselves through the Earth. I think also beyond the practical applications, we should never forget that being connected with the stars and understanding our place in the universe is very important for humans, has always been important for humans, all throughout time. And I think it's narrow-sighted to focus just on something that can either make money or help the economy or help defense. We need to think of the greater aspirations of humankind. And I remember, for example, one of the first director of Fermilab, which is a particle physics laboratory in Illinois. He was summoned by Congress to give a congressional hearing testimony on the construction of a very large particle accelerator that would cost many billions of dollars. And one of the congressmen asked him, how will this particle accelerator help defend our country? And he said, well, the fact that we will be able to do research and understand the destiny of our universe and the building blocks of our universe makes our country worth defending. And I think that that is a good reminder of the more philosophical and kinder purposes of scientific endeavor.
I want to first go back and then come back to the future. So when I go back, I'm talking about thousands of years ago, when human beings actually used stars as for navigation when they travel by sea. We often forget that before the plane and the trains, sea was the main way, land and sea.
Yes, land and sea. And the sky, yes.
The sky. So what have you learned about how older communities around the world use stars as their navigation tool?
Well, I was fortunate enough as part of work funded by NASA when I started at the Exploratorium to work with a group of native Hawaiian navigators and knowledge holders who are experts at using the stars for navigation. And so they have a system of canoes. This is the Polynesian Voyaging Society, and also the canoe called Hokulea, which was built in 1976. Actually, Hawaii gave that to the nation as part of the 200th anniversary of the founding of our country. And basically, how they use the stars is, of course, latitude is easy because you have that North Star. And if you use your hand and you extend your arm and you put it against the sea, the horizon, and you can know how many fingers up until you measure the North Star, and you can just keep going like that, and that gives you an angle and a calibration.
So this was like the sextant.
Yes, so they would use their bodies as a way to measure angles. And so...
And that was accurate?
Yes, absolutely accurate. Accurate for arriving at certain island groups that they had already visited, and they noticed where these stars were in relation to their location. And their system of navigation is home-based. So in
What
the
is
sense,
home-based?
In the sense that they can always get back to their home island, even though they might not find the destination. So in that sense, they are never lost. So they will never be like completely lost in the middle of the ocean.
So the stars anchored them.
The stars anchor them, and when they leave, they usually leave at sunset so that they know where their island is with respect to where the sun set and where the stars are appearing. And so that configuration is kind of like home base, and they can always return to that. And they also use a system of zenith stars. So for example, Hokulea is the zenith star of Hawaii. It means...
What is a zenith star?
A zenith star is a star that's directly overhead. So as you travel over the ocean, if you're coming north, the North Star will go up, up, up in the sky. And so when this particular star, Hokulea, which is Alpha Boötis, or the star Arcturus, is directly overhead, they know that they're at the latitude of Hawaii, which is 20 degrees north. And to go to Tahiti, they know that Sirius is the zenith star, so the fire in the sky. And so they know that they are at the latitude of Tahiti. And so then they would turn their canoes with the wind behind them, and they would take them to the islands.
So did the European navigators know about these ancient way of...
Actually, no, they did not. Captain Cook from England did a lot of navigation and exploration, particularly because there were...
He landed in Hawaii, didn't he?
Yes, he landed in Hawaii. But what he was amazed was the fact that when he had visited islands in Micronesia and the southern part of the Polynesian Triangle, the languages were very similar to the ones that he heard in Hawaii. So he knew that these people had traversed those thousands of kilometers, thousands of miles a long time ago. So that was fascinating to him, that he knew that they had been navigation through the language comparison.
So that is in the old days. Fast forward to the 20th century, Hubble and the telescopes that he used and how he discovered different galaxy and everything. And then there's the Hubble telescope.
Yes.
Which discovered, I think you call, pillars of creation?
Yes, beautiful,
so
beautiful
tell us,
imagery.
Yeah, so tell us, how has technology opened our eyes to this universe and all the infinite possibilities, because they usually use the word infinite when you talk about the universe.
Absolutely. I would say that technology is always the double-edged sword of our existence, right? So it has its amazing opportunities, and it enables so many great things like greater health, greater well-being and humanity, greater opportunity to see further and deeper into the universe. But also it starts to become a barrier, or it isolates us from that direct experience as well. So I would say that there's two parallel paths that I always recommend students follow. One is the intimate path of your own observation practice as you go outside and continue to observe the stars with your own eyes and notice the motions of the universe and the motions of the stars and the planets and the sun and the moon. And then you use technology to extend your senses. And so what the Hubble has done is provided us with some of the most beautiful imagery of nebulae, galaxies, star clusters, regions of star formation. Like you mentioned, the pillars of creation. These are
What are they?
Columns of gas and dust. And they're enormous, even though they look like these columns of gas and dust, beautiful colors and individual stars kind of piercing through. But at the very top of it, it's almost like you can think of it as a matchstick. And the top of the match is large enough to harbor an entire solar system. And
Really?
from there, new stars are being created.
So it's like a nursery?
It's a nursery. And we have many such nurseries. For example, even in that constellation of Orion that we can see in October when we go out in the night sky, Orion the Hunter, on its Orion sword, the middle star in the sword is not actually a star, it's a nebula. And in there are new stars being created as well. So,
Which we can't see.
Which we can't see, but if you have even a pair of binoculars or if you have a small telescope, you can actually see that it is not an individual star, but a fuzzy nebula. And so that gives you a different conception of what's going on out in space.
How excited do you get when you see all this new technology bringing back pictures? Because now we have a telescope in the sky, in space, right? How many telescopes do we have?
Well, there's many satellites out there that are dozens that are observing the universe at different wavelengths. So the nice thing about the Hubble is that it did have an optical telescope that could take photographs, because I think that has changed our whole worldview of the universe. But also, it's important to understand the details of composition, the morphology, and how the universe is dynamically changing, evolving, moving. The extent of the universe, all of those things can come by observing very distant quasars and galaxies. And a lot of time, because our own galaxy is so full of dust, optical light cannot travel through. So we start to observe galaxies and distant objects through other wavelengths that do penetrate the obscuring dust. And for example, we observe things in infrared, we observe things in radio, and then other kinds of phenomena like X-ray or ultraviolet that we either probe through areas in the galaxy that are clear of such dust, but can give us information of like when black holes collide, or when you have something that gives you a gravitational wave ripple that was recently found, for example. So there's just different techniques, different technologies to probe different wavelengths in the universe.
I want to come back and tie everything up together, because you grew up in Cordoba, Argentina, which has one of the oldest observatories.
Yes.
And then when you were studying, and then when you worked at Berkeley, you worked at the Lick Observatory in San Jose,
Right.
which is one of the oldest observatories.
Yes.
The gentleman who funded the Lick Observatory has connections to Latin America.
Yes, it's interesting. So James Lick was a philanthropist, and he originally was a piano builder, and he found that many of his pianos were being exported to South America, so he ended up traveling there, and he lived in Argentina for quite a while. And so basically then he came back to the U.S., and he brought with him all of the pianos that he finished here, plus 600 pounds of chocolate. And he told his friend Delhi that chocolate was very popular here.
This is during the gold rush.
During the gold rush, and so Ghirardelli went down to Peru and started to manufacture chocolate here, and that's we have the. But also, so we have chocolate, and then we have the Lick Observatory, which is the first observatory that of significance really in the U.S. The Cordoba Observatory was a few years earlier. It was in 1871, and this Lick Observatory was founded in 87 or 86, 1886, and then was given to the University of California, and that's where I did my dissertation. And the funny thing is that Lick himself, when he passed away, he said that he needed to be buried underneath the 36-inch refractor, which is the historical telescope up on the mountain, Mount Hamilton, right here in San Jose. And indeed he is, and so it was kind of creepy to go down there in the middle of the night and kind of dusty and stuff. But the one thing that we found was a big bouquet of plastic flowers, and we just asked, what was that about? And they said, well, in his will it said that he always had to have fresh flowers, except that nobody took the time, so at least they put a bouquet of plastic flowers down there. I can attest to that.
So there is that Latin American connection.
Yes, it's amazing. And now there's so much astronomy going on in the southern hemisphere because, of course, the stars in the Milky Way are different there.
3 quick questions. What is your favorite occupation?
My favorite occupation, astronomer.
What is your motto?
Oh, live each day as if it's the last day of your life.
Where would you most like to live?
Mexico.
Wow.
Mexico, I love Mexico.
Isabel, time went by so fast.
It did, didn't it?
Yes.
Yes.
Thank you so much for stopping by and talking to us about stars, space, and chocolates.
Thanks for the opportunity to reminisce and to have a wonderful conversation with you, Kamla.
Thank you. And thank you for watching. If you missed any of our conversations, you can watch them on our YouTube channel. We'll be back again next week with another new conversation. Until then, goodbye.
Support for the series on women in science and tech comes from Genentech, dedicated to breakthrough science and social good that supports local communities. Because making medicine is just one way to make a difference. Genentech, the future of science is here. Online at gene.com/future.